as we saw with the demonstration before, as we start to look at multiple components that are in different repositories and the microservices architecture where I have one component per repository, I need to have a continuous delivery methodology that embraces and supports this. And this diagram that we have here is something that's from our IBM Cloud Innovate. It used to be called the Cloud Garage method. But it's a cycle, right, where we include into continuous delivery, understanding about what's going on, allowing our teams to be able to collaborate effectively, to test and shift left when we are testing. I'll talk a little about shift left testing and the implications here in a moment. Being able to, once testing is passed, being able to continuously release and deploy, monitoring, and looking at feedback from users and using that to optimize what we do as we move forward with the design of an application. So the key point here is, if you're going to move into this new world of enterprise applications on a cloud environment, it needs to be done with automation and automation first. In fact, you need to build these processes and procedures first before you embark on the journey, because it's essential for moving forward. And one of a few tips around what we're doing here and the examples that we're showing, right, is that when you think of a microservices application, it's going to have individual components. Each component will have its own repository, and each component may have different requirements for build and deploy. For example, with a microservices architecture, I now have a polyglot style. In the old monoliths, I had to have the same programming language top to bottom. Now I can have many different programming languages, so I may have different build needs. Each particular component will need its own deployment scripts. So in the example we're showing here, where you have a Jenkins file is part of the code, and check it into the source code management system and automate your deployments using that so that you can get microservices up as quickly as possible. The other part of processing microservices, when you think about it from a testing perspective, is that you have some new opportunities for testing with microservices. Not only do you have the capability to do unit tests during the build phase and also look at code quality through static code analysis, is that into a staging environment, we need to do end-to-end testing and integration testing. So if I have 3 components that are live and I've added a new version of one of the components, I also need to set up tests to make sure that my end-to-end environment is working correctly. So it's another part of effectively managing and governance from a microservices perspective that's changed. Previously with monoliths, we had much more complex testing environments, and you really couldn't test until it was all together in one place. Here with the microservices, I can unit test and then also test end-to-end before deploying to production. The last thing that I want to touch on here is there's some really good guidance to think about this overall journey. And the 12-factor app methodology was created by some developers originally from Heroku, who observed the key characteristics of applications that were successful in running in a cloud environment. And we don't have time in this session to go through each of these item by item, but there's a few that I'll call out. One of the ones is something that David mentioned earlier, which was with regards to configuration. A traditional enterprise application will often have property files, all over the place. And that was one of the things that made deploying these tricky from environment to environment. Successful cloud environment deployments are based upon a different approach. The code is one version of code without any configuration inside. And then the configuration that's needed for a particular deployment, whether it's QA or integration testing or production, those configuration attributes are pulled in through the environment. Something else while we're talking about the difference in environments is if you take a look at item number 10, which is dev prod parity. It's really important in this model to have a consistent view of what is used for development and for staging and for production, because small differences will sort of create this. It works on my machine, but then it doesn't work in production. So it's very key when you're going to this cloud model to keep and use the capabilities to have the same technology stack across the deployment. And the last one I like to call out is really important is item number 11, which is log. So logging is something that you do differently in the cloud environment. You no longer log to local files. Instead, since these containers are ephemeral and will often have temporary storage locally, what you need to do is you need to log to an event stream. And the easiest way to do this is to write unbuffered events out to standard out. And then the container orchestration system will capture that and either bring it into a local environment, or you can also send this out to one of many log and log analysis services. So this is our last diagram that we've got in terms of the journey. So we've talked about repackage and replatform and repackage. And this last example is refactor. And in particular, we talk about a methodology that we've seen very successful with clients, something called the Strangler Pattern. And the Strangler Pattern draws from the sense of, if you've ever seen one of these creeping vines that grows up inside of a tree and around the tree, and eventually there's so much vine that there's hardly any tree left to be seen. This is an approach that sort of draws on that. And what it does is we start with the starting monolith, and we look at a logical module by logical module basis. So for example, here I've got a WAR file, which I've taken that WAR file and I've refactored that WAR file into a web app plus some microservices. And what I will do is the original app traffic is now going to be proxied into, instead of running on the WAR file, it'll be proxied over into the cloud environment. And this is a way to do a piecewise approach where you take a chunk of functionality and you bring it over to the cloud environment, implement it as a set of microservices, and then route the traffic for that part of the request in the application over to that component. And then you complete this step for the other logical components. And eventually you'll have migrated the application over time, and there won't be any parts of that original EAR file left to service the application request.